Hello, my name's Mike Taulty and I work at Microsoft in the UK. And this is one of a number of videos around a technology called Prism, sometimes known as the Composite Application Guidance. This comes from the Microsoft Patterns and Practices team and largely targets building Silverlight and WPF applications. But you can use some of the techniques and the pieces delivered outside of those spaces. So you kind of get two things with Prism. You get some documentation and you get some libraries in the form of source code that you can build up for WPF or Silverlight. And as I say, you don't have to use these inside of those kinds of applications, but some of the technologies in Prism are specific for UI work with these two technologies. Prism has a friend called Unity, which is another framework, and we'll talk about that as well in these videos. And in terms of finding these things, if you want to find Prism and so on, if you just pop to a search engine, type in Prism and Codeplex and you'll find Prism. If you want to find Unity, type in Unity and Codeplex and you'll find Unity. If you want to find these videos, you can go to channel9msdn.com/niners/mtaulty, that's me, and I'll put these videos on this site here. If you want to find me, you can go to mtaulty.com, that's my blog, and you'll find it there. If you want to find me on Twitter, you can go to twitter.com/mtaulty and you can find me on there as well. And if you want to find me on email, I'm just mtaulty@microsoft.com. Okay, so in video 2 here, what I want to do is build upon the code that we wrote in video 1, which was a simple sort of calculator-based example. So if you haven't seen video 1, you perhaps want to watch that before dipping in here. And at the end of that video, we'd kind of refactored our code such that we were being a little bit more loosely coupled. We're using interfaces rather than concrete classes to program against. And we'd refactored some of our code such that it was fairly easy for a programmer using our class to replace some of the dependencies that the class had. We talked about the idea of having some kind of container, some kind of service that provided this functionality for us, that we could go up to the container and register implementations and then look them up based on interface. And the framework that by default underpins Prism for this kind of functionality is a framework called Unity. Now this stands in its own right, and it's also worth saying that Prism is not dependent on Unity. You can remove Unity and use Prism with other container frameworks, but by default Prism will use Unity, and that's what we'll look at here. Other frameworks are kind of similar. So let's go and revisit our code and see how we can bring Unity to provide this kind of container service into our code. Okay, so the last time we were here, we'd written a program that instantiated this calculator REPL loop and then told it to run. And inside of the implementation of this REPL loop thing, it depends on a calculator service, a console input service, a console output service, and an input parser service. And we'd made these public properties so that a programmer could replace them with other implementations of the same interface. And then when you actually call run, our program goes ahead and reads a command from the input service, parses it using the parsing service, reads arguments from the input service, and then uses the calculator to execute that command on those arguments and writes out the result of that using an output service. So we kind of got these four services, these four dependencies that our calculator REPL loop now depends upon. However, at the moment, the choice is being made here that by default we will just instantiate our default implementations of these services. So the calculator, the console input, the console output, and the input parser service, which we kind of factored off into different libraries over here on the right hand side. So in bringing in Unity into this, I guess what we want to do in the first instance is I'm going to just abstract this calculator REPL loop just like we did previously. So let's extract an interface from that in the first instance. Let's refactor that to pull out an interface. We'll call it iCalculator REPL loop, and I'm just going to put the run method on there. Notice I'm not going to put these properties on here because I'm going to get rid of these in a minute, so let's just say we want the run method. I'll then take that interface and let's just cut it. Let me get my Solution Explorer to stand out for a second. I'm going to cut that interface from the calculator library and drop it into my interfaces library down here. So let's just paste that in down there, and hopefully at that point everything still kind of builds and works the way it did before. Let me just fix that namespace. And let me make sure that that interface that's been pasted is actually public. So let's just pop down here and make sure it's public, or else that's not going to work. So we did this previously with other implementations and interfaces, and what that means, of course, is if I go back to my program, I can now use an iCalculator REPL loop to refer to the implementation rather than an actual reference to a class. I've got a reference to an interface implemented by that class, so that's all fine. Now if we go and revisit implementation of calculator REPL loop, what I'm going to do for a moment is I'm going to take these property sets away here, so we have no default implementation anymore, and I'm going to change these things. Let's just refactor this to rename it and put that as a lowercase c just for a minute. I'm going to make it a field again in a second. Let's take this guy and do the same thing, so I'm going to make this a field as well. Let's take this guy and make it a field. We'll do that in a second. Let's just change the name, and this guy as well. Let's just refactor that to rename. So these are going to go from being public properties to being private fields in just 1 second. Let's just change this to be as so, and let's get rid of this. So they're not properties anymore, they're just private fields. Other than that, everything should be just fine. Great. And so what I want to be able to do, just like we could before, is have the programmer that's using this class able to provide different implementations for these services. So when perhaps you construct the type, you can pass an iCalculator, that will be your own version of calculator. You can pass an iInput service, that will be your own version of input service. You can pass an iOutput service, that will be your own version of output service. You can pass an iInput parser service. Let's just call that input parser service. And then of course we'll set up private fields from those. So we'll say this.calculator equals calculator. We'll say this.input service equals input service. We'll say this.output service equals output service. And we'll say this.parsing service equals input parser service. That guy there. So nothing really dissimilar from what we did before. We've just moved this to a constructor, and these are now private fields as opposed to public properties. Now what I want to do is bring Unity into the projects at this point. So let's just go to our Solution Explorer. I think we're in the calculator library right now. So I'm not necessarily going to use Unity in there just yet. Let's go to our application here and let's add a reference to a couple of assemblies. So I'm just going to browse for these. When you install Prism, for me I installed it into Program Files Prism. Within there's a folder called lib, and in there desktop or Silverlight versions. And I'm wandering into Unity. I'm picking up Unity and ObjectBuilder2.dll and bringing those two things in. Okay, great. So back in my main program, I'm going to use a Unity container to instantiate types for me and register types for me, rather than looking things up and doing things manually myself here. So I'm going to create a Unity container. Let's go and create one of those things. We'll call it container. Make a new one of those things. Now the way that this thing works, if you look at the methods on it, if you ignore the extension stuff and to some extent building up and configuring right now, the key methods on here really are register int type and register instance, and then resolve and resolve all. Those are the kind of key methods, i.e. I want to register a type with you, and then later on I will come back and resolve and try and find what type do I get for a particular interface. So instead of creating our iCalculator REPL loop this way, we will ask Unity, the container, to resolve for us iCalculator REPL loop. Okay. We give that responsibility now for creating the concrete type that implements this over to the Unity container, rather than doing it ourselves. Now of course if it's going to do that, it's going to need to know how to do that. So we'll walk up to that container and we'll say container.register type, and we will register a type here. We'll say iCalculator REPL loop, and that's going to be calculator REPL loop. So we've gone ahead and registered that particular type. Let me put that onto a separate line just so you can see that. So we're saying when somebody wants one of these, give them one of these. Simple as that. Let's put that back. Okay, but in doing that, when you go and look at calculator REPL loop back in here, it's going to fall over if we use this constructor and don't provide these various things. So in fact, I'm going to kill that constructor at this point just for a minute. So we can't really instantiate one of these things without these various services. So what I can do is go back to my Unity container and I can say, well, if somebody wants, let's register, and we'll go ahead and say an I calculator, then give them a calculator. And if somebody wants an I input service, give them a console input service. And if somebody wants, you get the flavor here, an I output service, you give them a console output service. And finally, if somebody wants an I input parser service, something like that, then you give them our input parser service. Okay, so we've added all those things hopefully to our container. And let's just set a breakpoint in the constructor for this class and see if we've made this work. Let's press F5. So you can spot that something, and it's not us, it's Unity, is instantiating the calculator REPL loop with an instance of calculator, an instance of input service, an instance of output service, and an instance of the input parser service. So by registering those things in the Unity container, when we ask it to find us one of these iCalculator REPL loops, it will go and identify that's this class here. When it looks at this class here, it will see that it has a constructor with dependencies. It depends on an implementation of iCalculator, iInput service, iOutput service, and iInput parser service. And so when it goes back to its container, it sees, that it knows about all those services, and so it provides them to the implementation at the point where it's doing the resolution. So it recursively goes down, identifies dependencies, and provides them to that implementation at the point where it needs it. And our code continues to work and run, of course. Let's just run on from here. We can add two numbers together like we could before. But now, of course, what's really quite sweet is that our calculator REPL loop depends upon these four services, has no idea where they come from, and the instantiating code largely doesn't care about that either. It just asks the container to resolve that particular interface, and in doing so brings in all these types that have been registered beforehand with the particular container. Now, if you wanted to register a particular object instance rather than a type, because at the moment when the framework comes to resolve, it's feeling free to instantiate as many calculators as it likes. If you wanted to make a calculator, you can just make a calculator and make one of those things. And instead of doing register type here, you could do register instance and say that when you're looking for an iCalculator, you should provide this calculator here. And that means that only one calculator will ever be instantiated through the resolution framework that we've got here, through this particular container. So it's still going to work the same way as before, but now we're using an instance that we pre-created as opposed to having the Unity container create one for us as and when it feels like it. So let's just revert that code back to where it was with a few Control-Z's on it. So we're back to where we were a second ago. Now, one of the nice things about the way we've done this so far is you'll notice that calculator REPL loop is completely unchanged from how it was before. Nothing's changed here. So we haven't had to change our class that's being used by or being provided or built up for us by Unity. We've left it entirely as it was. But let's look at another way of doing it, which is more like our property way of doing things. If you go back to our implementation, let's take this back to a default constructor for 1 second. Let's take these guys out for 1 second. So now we've just got a default constructor. Let's change these into properties again. So now we've got a property. Let's take this guy, a property. Take this guy, make it into a property, and finally this chap down here and turn this into a property. So we turn those things into properties. And so what we can do is we can mark up these properties to say that they are dependencies or not for our particular type. So let's just go and add references to this library that we're into the Unity bits again, so we'll just go out and browse. I need to go to C, Program Files, Prism, Lib, Desktop, Unity, bring in these guys again. And what we want to do is have these marked as dependencies. So we walk up to these and say dependency, I think that's the right name. We'll use the Unity one, not the reflection one. So that's a dependency, that's a dependency, that's a dependency, and that's a dependency. This guy here. Let's just drop a few breakpoints on these setters for a second. Put a breakpoint, a breakpoint, a breakpoint, and a breakpoint. Press F5. And what we should see is that somebody is setting those values for us to real values, and of course it's the Unity container. So it sets the calculator, it sets the input service, it sets the output service, it sets the parsing service. And consequently our code still can multiply, 10 by 5 or something like that. So that's pretty neat. That's another way of achieving the same thing. But what we'll do is we'll take this back, so I'm just going to do a lot of Control Zing in here to take this back to where it was before. Let's get rid of all these different bits and pieces. Let me just whistle through all that back, and I think we're probably pretty much back to where we were a few minutes ago with a constructor that takes all those things again. And so now we don't need those references to Object Builder and Unity in this particular library because it's not using them anymore. That's fine, not a problem. So we should be back building and running again, this time without properties. We can still add 10 and 20 and get 30, so that's great. Let's go back to our calling code again. At the moment we're being quite manual and actually writing code to register which type implements the interface that we want, in this particular case calculator and iCalculator. And that kind of has a knock-on effect in that our main program up here right now, our application, has references to all of our interfaces in our interfaces library because I put them all in one place for now. But it also has reference to the calculator part, the parsing library, the calculator library, and the input and output library. So it actually has a reference to all of those assemblies in order that it can use these types here. But there's another way of configuring Unity. We don't have to configure it in code like this. We can configure it using an application config file. So let's go to our application here and let's add to this a new item, which will be an application config file. Let's just let that whir and add one of those things in there. Okay, so let's add a config file in here, and let's go and add a little bit of configuration in here. I'm not going to type it all out because it's error prone to do that, so let's go and paste a bit of configuration into this. Okay, so let's just paste a bit of configuration in here. And what we're doing is saying that there's a new config section for Unity, fairly standard stuff. And then in the Unity config section we're saying that we can define any number of containers. So we're only using one container at the moment, but you can have lots of them, and you can nest them, you can do all kinds of fancy things with containers. And in there, that container, we're saying there's a bunch of types, and this will default to registering types rather than registering instances, though you can do that with the config file as well. And what we're saying is that if somebody wants an iCalculator, then this is the implementation. If somebody wants an iInput service, then this is the implementation, and so on and so forth for the other interfaces that we've got here. So that's kind of how we're doing it. We can then go back to our code. Let's just save that config file. Pop to the code, and instead of registering all these types this way, we can go and read the configuration file. So we'll need a reference to system.configuration. That's that guy. And we'll need a reference to the Unity configuration library. So let's browse out to unity.configuration. That gives you a thing called a Unity configuration section. Let's resolve that. We'll call this config section, and we'll say equals Unity configuration section from configuration manager dot get section from the config file called Unity. That gives us a config section. We can then take that and ask it to get its containers, there's only one in there, and get it to configure our container. So use that configuration information to configure this container. If we press F5, we should find hopefully that our code is still working as it was before, and we can add 10 and 20 again to get 30. So what we've done is just moved this stuff into that configuration file. But notice something else that we did at the same time. That means that our code up here no longer really needs a reference to that library or that library or that library, and it should still work. Let's just clean out the bin folder. Well, let's just have a look at the bin folder rather. The bin folder still contains those things. So if you just go and press F5 in here again, you should be able to spin the application back up and attempt to add things together again, just like we could before. And yet this time around we have much less of at least a stated dependency. So we have a runtime dependency, but not a compilation time dependency on anything other than the interfaces library from our actual application project. So we've reduced down the references from that thing just to a single library that we own. The rest of the stuff is all obviously Microsoft standard framework stuff and the bits that we bring in from Unity. So that's pretty neat. We've managed to reduce down our compile time dependencies there, and we're managing to be pretty, if we just minimize that over there for a second, pretty loose really about the types that we actually need at runtime. They're just coming from this XML configuration file at the moment. Let's just show another aspect of this. What if, at the moment, if we go back to our Solution Explorer over here and just focus on our input-output library, our input-output library actually has two different kinds of output services. We have the console one and the message box one that we wrote in the previous video. Now, what if we wanted to actually configure both of these things as opposed to only having one of these things? So let's go back and revisit our configuration file. At the moment what we're doing, if I just scroll this a little bit, is, let me just space some things out here. We're saying that we've got the I output service mapped to the console output service. So let me just go and copy that thing. We'll copy that. And we'll also map I output service to the message box service as well. Let me just go and make sure I can figure out the type name for that message box service. So it's message box output service from the input output library. So let's go back over here. It's going to be that guy, and we're going to also have that name there as well. Okay, so now we're saying we've got I output service number 1 and number 2. Now, in order to differentiate these things, you can't have two things registered for the exact same service quite like this. What we'll do is give them names. So I'm going to call this first one here, let's say name equals output service 1. And let's give this one a name here, which will have output service 2. Let me just reformat that XML a little bit. So I've now configured two output services inside of my config file. So what happens now at the point where we construct our calculator REPL loop? As you know, the calling code just looks like this. We ask for an iCalculator REPL loop and we leave the rest of the work to Unity. Well, if we go and take a look at calculator REPL loop, that's the implementation that's registered with Unity. We know that it has dependencies on 4 separate things: calculator, input service, input parser service, and output service. Now you might think that what you might be able to do is say, hey, I'm expecting an array of these things. But it doesn't actually work like that. So what we'll do is we'll take away the output service from the constructor here, and we'll take it away here as well. And instead of just having an output service, let's have a list of output services. So we're actually going to have a set of output services. Okay, so that's great. And instead of using output service.write message, let's write a little function in here. So let's just have void, and let's say write message to all output services. Take the message, and then all we'll do here is we'll say for each I output service, let's call that output service, in output services, let's say output service dot write message using the message. So we've written a little function now, so instead of actually asking the output service to write messages, we can just use write message to all output services, and here we can use the same thing, write message to all output services. So we've changed our calculator REPL loop so it has a list of output services. That's all we've done. But how do we get this thing populated? How do we find from this calculator REPL loop which output services are registered with the Unity container? Well, the way we do it here, or the way I'm going to do it here, is by getting hold of the Unity container. So how does this class get hold of the Unity container? Well, it just so happens that just like Unity can inject implementations of our interfaces for us, it can also inject effectively the container itself. So we can add an extra parameter here of iUnity container. Now let's just make sure we've got a reference to support that. So let's go back to my calculator library and just make sure we've got references here. Let's add a reference. Pop out to the Prism libraries again and find Unity. Let's just wait for the dialog to pop up. Okay, so let's just browse out to C, program files, Prism, lib, and then pop into desktop and Unity. Let me just add a quick reference to those two guys there. And so now we can add that interface, and I'll call this container. So we're going to get this injected by Unity itself. And that what I would want to do is I want to say that my output services will be a new list of iOutput service based upon container.resolve for me all of iOutput service, which will give me an enumerable of iOutput service. So I'm just grabbing those from the container at runtime and saying those are all of my output services. Let's just build that. Okay, so having changed the implementation of my calculator library, I need to be a little bit careful here. Let me just go to the bin folder and grab calculator library.dll and pdb. Just copy those, drop them into the bin folder up here, because essentially we no longer have a reference across there, so otherwise it won't automatically update, because Visual Studio has no reference between these projects anymore. And so with that said, we should be able to go back to our program over here, and we've changed nothing in the program here. All we've changed is the config file and one of the underlying implementations. We should be able to find, hopefully, that we can now add 10 and 20 and get both a console output and a message box output without really changing very much. Hopefully you start to see how this is starting to be quite flexible, and you saw how we could get into this implementation the actual Unity container itself. However, the sharp-eyed amongst you might have noticed that what we're slowly doing in these videos is moving towards less coupled code with less explicit dependency. And at this point here, you might have noticed that I just took a dependency in this library, which is my calculator library here. I just took a dependency on iUnity container. And you might think, well, hang on a second. What if I want to take a dependency on a container but not necessarily a Unity container? What if I wanted to replace Unity at some point in the future with some other container library? So very smart people have already been out there thinking about that. And if you go out to CodePlex again, there is a pattern and implementation of interfaces out there to actually abstract yourself from the Unity container altogether. So if you go out to a search engine and you type in service location and CodePlex and search for that thing, you'll find a library called the Common Service Locator, the home for that library, and you can download that thing. It's actually already present in Prism as one of the additional libraries, but if you wanted to get it in isolation, you can get it this way. So what code like that will do is allow you to abstract this kind of code from iUnity container. Let's go and add some references again. So let's go over here, and on our calculator library now, let's add a reference. Pop out to Common Service Location, which is again one of the library folders. Let's bring that in. And instead of using iUnity container here now, let's use iService Locator. Let's call that Locator. And instead of using container.resolve all, there's an equivalent on that interface called locator.getAllInstances. And we can just say of iOutput service. Okay, so that's great. And then when we initially configure our Unity container, we need to make a change there as well to make sure this interface is part of the configuration, if you like. So let's go back over to our program. When we created this container here and configured it from the config file, let's go and register one more interface with that container. Let's go and say container.register instance of iService Locator. So we need a reference to that interface here as well. So let's go to our application, add a reference to the very same library. So that's in C, program files, Prism. Let's just find that, lib, desktop, Common Service Location. Let's go and just resolve that namespace there. So registering an instance of that, and the instance of that is actually the Unity container itself. So the Unity container implements that. Although actually it's not quite as simple as that. What we need to do is put a little wrapper around it. So there's a new class in that library we just brought in. So this additional complexity kind of comes from Unity not directly implementing this interface. We need to wrap a little type around a Unity container to make it implement this interface. So we add one more reference here. Let's go out and add a reference. Just pop up to the Prism libraries this time. And in the libraries for Prism, there's some Unity extensions in here. Grab the Unity extensions library here. And that gives us another type called something like Unity Service Locator Adapter, and pass the container into that. So the job of this type here, did I spell something wrong? So the job of this type here is simply to take the container and implement iServiceLocator for it, such that we are now abstracted from the fact that we're using Unity at all, really. All we know about the Unity container in the rest of our code is iServiceLocator. And there are other inversion of control containers that also implement this particular interface. Let's go build again. Let's see if we can run again. I think we changed our code again in a library, so let's just make sure we copy that output in the calculator library. Let's just grab those 2 bits. Let's copy them. Let's now run up and paste them into this debug folder up here. Press F5, adding 10 and 20 and getting 30 with the 2 output services as before. But now our code knows nothing really about Unity, it just knows about iServiceLocator, so it has even less of a dependency than it did before. And so in this video we've managed to get our application here, the thing that actually ends up being our executable, to a position where it only has a reference to our interfaces library at build time, and it knows about some pieces of Prism and some pieces of Unity. The actual application code, when we look at it, is just creating a Unity container and configuring it, and then simply asking for an iCalculator REPL loop, and then telling that thing to run. That's kind of interesting. The rest of where the implementation comes from, if we look at it, is really in the application configuration file as to how Unity is supposed to do these mappings for us. And so we've moved to a much more loosely coupled piece of software than we had at the start of the video. However, we are starting to create a few sort of problems for ourselves. What we've done is we've created a set of essentially independent modules, and it sort of highlights itself best in the calculator library, where we have our implementation of this REPL loop that's dependent on all these services. Now, we've been careful at this point to make sure that we only instantiate one of these things at the point where the Unity container contains all the services that that particular type needs. However, if we're building a system out of hundreds of modules, it starts to become very difficult to know what needs to be registered before some other type can be instantiated. How do you know? We've also built a system where you might have noticed I'm now having to be quite careful and manage dependencies in my head and copy output assemblies into the right folder at the right time so that the code actually works at runtime. At the moment our code is just using sort of .NET standard sort of fusion resolution of types, in that we're expecting that types will just be contained in assemblies in the same folder of the application or in the GAC or something like that. What if I wanted to load some of my types from a different folder on the disk, or what if I wanted to load some types from a website or something like that? There's nothing that I've got that could do that kind of thing. Also, what if I wanted to load some of my types on demand in order to make the initial loading of the application quicker or something like that? So what this really argues for is to have something a little bit beyond what Unity does in terms of decomposing the application into a set of modules, having flexible ways for these modules to be loaded at runtime, having ways for these modules to describe themselves in terms of dependencies upon other modules, and allowing modules to initialize themselves into the system such that they can register types, and so that other modules can then later find those types. Still done through a container, but just adding extra services on top of that. Now, this idea of modularity is something that's encapsulated in Prism, and so what we'll do in the next video is we'll start to take this code that we've got here and break it down into a set of Prism modules and look at how that works as a way of giving us these additional benefits of a more structured approach to modularity.